Good afternoon. So we have a robot system. We have to deploy that in a greenhouse or a cropping system. So that is what I will talk about today. So this is my outline. So okay. So if we go inside the greenhouse, we can see very many things, plants. So like a greenhouse here, you can see plants, and it's quite a big greenhouse. In this greenhouse, it's quite a small greenhouse. You can see racks, you can see small plants, but this is a very inhomogeneous system. The greenhouse is a very inhomogeneous system. It can be different. It can have different things. So there's a dog also. So greenhouses. So this is very inhomogeneous. So we have to compensate with this greenhouse system. So normally in the today's concept, today's researchers, they have different kind of robots. So mainly they use a camera. As you can see here, there's a camera. There's a camera. So camera is used, and the information is gained from the camera and sent into the to the processing. And this system works. And there's another system which uses a guide rail system, the rail system here, and use an indicator-based system where we place different indicators in the path so the robot can know where it is. So this is our system. So I think you have seen this. This is from Vidosana's presentation. So this is the speaker. We have 4 nodes where these are the microphones. This is the microphone, and this is the speaker, and this is the microphone. So the sound is emitted from the speaker, and the microphone captures it. So this GIF will show you how does that work. So this robot emits the sound, and the microphones catch it, and then the calibration station emits the sound, and the microphone decide, okay, this robot is this far from me. So it can't decide where it is, but it can say, okay, this robot is that much far from me. And the second microphone also does the same. The second microphone also does the same and decide, okay, this robot is this much far from here. And the third with the third microphone, you can locate the robot inside the greenhouse or the system. And if you use a fourth microphone, we can also decide the height of the robot from the ground. So this is what happens when we put the robot inside the greenhouse, maybe what may happen. So these are the crop rows. Robot has to go through them, but because of these crop rows, the robot, the sound may the sound may change the direction. I didn't put the calibration is also there. So this is what may happen if we put a robot inside the greenhouse. So this is the problem with the greenhouses. You have very many things. You have plants and high humidity, temperature gradient, wind, and obstacles. There are many things. So if we consider about the temperature gradient does pose a problem, because the cool air, in the cool air sound travels slowly than the warm air. The temperature will change the sound direction. That's a problem. In the greenhouses, actually the temperature changes with the time, and we normally have a temperature control system. And this the warm air. So the plants poses a different problem. Reflection. where the sound emitted, as you saw in the robot emits the sound, and when the sound is emitted, it can be reflected from the plants, or it can be scattered. Scattered means the sound hit the plant and it's scattered to different directions. And the sound can be diffracted. Diffracted means when you have an obstacle, sound tend to bend in the near the obstacle. That's the diffraction. So because of these things, the sound will cause multipath effect. This is the multipath effect. You can see the sound can take different paths. So as you can remember the first the GIF I saw you, if the sound takes these different paths, this has to draw its circle around here, but the robot is there. Because the sound takes a curved path, this is not going direct. This is a problem. So this is the multipath effect. So the Vidya-san has done some work on this. And what I will try to do is, I'll do a preliminary investigation and then redesign the system. Means first I'll try to change the frequency, because the frequency has a big effect on the sound behavior. And then the change in the arrangement of the components means you just don't arrange them like that. Some different arrangement I'll try. And this multi-sensor approach. This means if you can't get the signal somewhere, we can use these other sensors, that like dead reckoning sensors or gyro sensors, to locate the robot. And the frequency change is the most desirable candidate, but there's a problem with the frequency. Increase the detection time, and it will increase the detection time, and frequency is lowered, it will be subjected to high amount of background noise. I'll show you okay. So this is what will happen. So you can't hear it, no? So these are more familiar noises. That means this adding background noise. Okay. Okay. So that's a problem. And if we reduce the frequency, there's another problem: the detection time. Can you see these two peaks? The time to come to the ear is increasing. So that means it increases our detection time. That's another problem. So okay. So ultimately, I'll try to navigate the robot inside a crop field or a greenhouse. That is the target. Okay. Okay. This is the summary. And thank you very much.